Okay, so how it actually started, right? If you look into the human behavior, right? How does a human operate and how does a human solve some of the complex tasks, right? While solving some of those complex tasks that a human does in a day-to-day life, it can be simple, it can be a flight booking, which looks a simple thing for us, but for an LLM, it may not be, right? LLM cannot do a flight booking by its own, right? But the AI agent can do. But how it does is we'll come to that. But if you look into a flight booking, which is a complex task, a human does it by using certain tools, right? Maybe he may be using certain tools, which may be searching for the flight search. Maybe he uses a Google, maybe, right? So maybe Google is one of the tool. It may be using some of the banking apps to scan the QR code or maybe a credit card or some way want to make the payment, right? Maybe using certain banking apps and so on. So if you consider a human, he is basically using certain tools for just a flight booking. This particular flight booking, he is using this tool, right? So this is basically the different tools that a human is using, right? It can be some other tools as well. I mean, not from the flight booking point of view, but in general point of view, he can be using a calculator in a day-to-day life, right? He can be using certain books to get certain knowledge in day-to-day life. So, just like a human is using certain tool, can I use a language model or a large language model or a visual language model? It doesn't matter. I will just write LLM, but sometimes also referred as LM. Can an LLM or language model also use certain tools in order to perform some specific task, right? What can be these tools that a language model may have to use? It may need to retrieve certain information from a database, retrieve info from DB. Now, database can be a SQL based database for a structured database, it can be a vector database for the text database and so on. So there can be one of the tools that LLM may want to use to retrieve certain information. It may also want to use certain APIs, right? Maybe it want to use a Google API to do certain web search, right? Web search. If you remember the Chat GPT when it advanced, one of the release was okay. Now it can also do a web search. Why was that mandatory? Because the usually the LLM training data cutoff is a little old. If I'm recording this video in 2025, if I'm using a chat GPT 4.0, its cutoff may be April 24, right? If I am in April 25, the training using over here and the training cutoff is here. That means the training data that was used for LLM is only until here. And if I'm going to ask the newer information, who is basically a prime minister of Singapore, maybe, and it changed after this, it will not have that information, right? So, what did they do? They integrated a tool which was just a Google API for an example. I'm just taking an example, which is able to do a web search for the latest information and is able to retrieve the newer information, right? So, this is one of the example of the tools, right? So, what we are doing over here with the tools we are trying to give the LLM external informations. We are giving an LLM external information. So now an LLM is having an external information, right? Just not an external information. It can actually perform certain updates and other stuff also. If I want to book the ticket, it can also call an API and book the tickets as well, right? So what are the different things that comes over here? It it LLM can do certain reasoning now. It is capable of doing certain reasoning. It is able to access to the external informations, right? So LLM gets combined with a tool, right? Just like human is using certain tools, now the LLM will also be using certain tools, right? That form certain foundation for the agent, that form certain foundation for agent. Now what is an agent, right? Or in particular, when we are referring over here, we can probably call it as a generative AI agent. So what is a generative AI agent, right? So generative AI agent is the application, right, which observes the world and takes certain action using the tools it has for the disposal, right? Observes, reasons, and takes actions using tools available at disposal, right? One of the main thing is it is autonomous, right? Autonomous. But even if you say autonomous, right, one of the key thing is always, right, that we say is human in the middle, right? So AI agent by a lot of way is autonomous, but usually when it comes to performing the last step where there will be certain updates, etc., to the systems, or AI agent want to send certain emails or perform certain updates in SAP systems or the transactional systems or the CRM systems, it will go to human in the middle who will be approving it, right? Or maybe it wants to take certain trade in the stock market. It will actually go to the human and human has to approve it, right? Of course, there are AI agents currently also operating, which takes the decision on behalf of human, right? But if you're working in most of the enterprises, it will never be, or I mean, if it is just an information retrieval, it will be autonomous. But if you are performing certain updates, uh, it's always human in the middle, right? Most of the time will be always human in the middle. Now, when it is an autonomous, right? Uh, Even if it has not seen certain scenarios or it has not seen certain examples, it will still be able to take certain decisions, right? Even though it has not seen certain examples and so on, it will still take certain decisions. That is what autonomous is. However, most of the times we will give some examples, right? Examples are provided usually as a prompts, usually as prompts. We'll see what it is as prompts. But even if the question is beyond the examples that are provided, it is autonomous enough to take certain decisions on its behalf, right? Now, when we combine few of these things, right? Few of these things, that is ability to observe and reason, ability to take actions or take the decisions. If we look into these capabilities that these AI agents are performing, it is referred to as cognitive architectures, right? So it is referred to as cognitive architectures. There are three main components of cognitive architecture. There are three main components that are related to cognitive architecture. Let's see what are those three main components. So, the first main component is the orchestrator. Okay, the orchestrator, right? The second main component, so there is a first main component that is orchestrator. The second main component, that is a model, right? Which can be a LLM, visual language model, any other model, right? There can be one model, there can be two models, there can be three models, there can be four models. And the third component that comes over here is the tool, right? So what are the different examples of tools we saw above, right? It can be a web search. It is able to do the web search. It is able to book the flights. It can have a calculator. It can have some books available in the vector database that can be retrieved, right? And so on. So these are the different, it can be, right? These are the different example of tools that we have given. And all these things together forms as an agent. All these things together forms as an agent or a generative AI agent, if we are referring over here in this context, right? Because agent as a word can mean many other things. Now, we spoke about a model, we have spoke about the tool. What does this orchestration layer does? So orchestration layer has few things. It is able to do certain reasoning and planning. Who is able helping over there for doing the reasoning and planning? It is the model, right? It is the model. It is the model that will be helping in doing the reasoning and planning. It has certain memory, which can be a short-term memory or it can be a long-term memory, right? Short-term memory and long-term memory. So short-term memory is usually referred as the memory that is there for the current session and so on. And long-term memory is referred as more historical memory that is saved. And finally, it also has profile, what is the goal, and certain instructions that are given to this agent, right? So if you just think of an intern coming and joining your company, you give him certain instruction, you define certain goal, you assign a profile, certain memory that he already has and he develops as a short term and long term, and he's using his brains for reasoning and planning, and there are certain tools for a disposal, right? So just think of it as an intern or an helper within your organization that is going to help out, right? I typically think of it as from the scaling perspective as a clone of you, right? So if you are in an operations and you are doing certain business, you can think of it as a cloner of you, right? So you are doing certain tasks. In a longer run, you will be making a clones of you, okay? And then if someone is asking, someone would usually ask you a question. Now, instead of asking you a question, he is going to ask your clone an question, and your clone is going to respond back over here with an answer to it, right? It can reply back an answer. It's a question, it gives an answer, it asks you to do certain booking, block certain calendar for someone. It blocks the calendar. It can be asking you to add a new team member who joined in the team, to add that team member in the PDL list. And this AI agent, instead of you doing it, your agent helps add that into the PDL list, right? So that's an AI agent. Now let's talk a little bit more about the model tool and the orchestration layer, right? Let's talk a little bit more about model tool and orchestration layer. Let me see if I can reuse this thing and into the next slide into the simple way while I into a diagrammatic way and I keep referring over there. So let me save as a save and I go to the next slide. I try to import it. Hopefully I put it in the diagram. Here you go. Okay. So we'll be referring this in next couple of slides and start talking something about each of these layers and little bit of detail. Now let's talk about the model layer, right? So as I spoke about the model, it is a language model. Language model. So is the GPT, which is behind the Chat GPT, right? Chat GPT, the behind the scenes, the model name is a GPT. GPT 2.5, GPT 3, GPT 4, GPT 4.0, GPT 4.5, then came GPT 4.1, GPT o1, o3, and so on, right? So these are the different language models, Llama, and so on, right? Claude, and so on. Google has a Gemini model, and so on. So different language models are used for decision making, right? For decision making. So decision making is done by whom? These language models. There can be multiple LL multiple language model can be used over here. It can be a small model, it can be a big model, right? It can be a large language model, it can be a small language model. There can be multiple models that can be used for reasoning and planning, right? We'll see in the when we talk about orchestration, we'll see more. But for doing this reasoning and planning, which is done by this model, right? There are different logic and reasoning frameworks used. Reasoning, logic frameworks, right? That are used. The one of the very common one is called as a React, reason action, right? React is the most common framework that is used in the agents. Another one is a chain of thought. There is a extension to chain of thought, which is a tree of thought, and so on, right? So these different agents can be used over there. This models basically these models. What does this model do also, right? So one is the sorry, just a second. Yeah. So these models are going to reason and do something. And these models are also going to pick up which tool is to be called, right? Which tool needs to be called is going to be done by this. So it is going to select the right tool, right? So while it is going to select the right tool, it's also your responsibility to define the tool correctly so that model is able to interpret and think on its own which tool is to be used. So it becomes very, very, very critical to um, define the tools correctly. Okay, let's go ahead. So it selects tool, selects right tool. Okay, so we spoke about a model. Let's speak a little bit about the tools, right? Let's speak a little bit more about tools. So these are the foundational elements, right? Because this is actually very, very important because it's allowing LLM allows LLM to interact external world with external world, right? It can be the data that is available in the world wide web. It can be your data in your databases. It can be certain actions it want to take, like an update API or booking the tickets and do certain updates over there, and so on, right? So it is giving you an access to the different tools, giving an access to the LLM to interact with the external tools, right? Usually it is interacted using the APIs, right? However, now it is mostly going in favor of MCP, right? We are going to talk about MCP later on, but MCP are certain protocols or certain standard that was defined by a company called as Anthropic in November 2024. I am recording this in March 25. But even if you see this video after 10 year also, it will still solve your purpose. Um, so usually the models will be talking to the tools using an APIs, but to make it consistent in the industry, it is also, I mean, the Anthropic came up with a framework or the open framework or the standards called as a MCP, model context protocol, which basically defines that how the model is going to interact with the tools, right? That's the protocol it is. um, I mean, just like you have a HTTP protocol, you have a SMTP protocol for sending an emails, right? Because if there was no such protocol, the internet was all on, I mean, would have not taken up, right? And then how this internet took up and how the world wide web came in and how it become the e-commerce became one of the biggest business, right? Similarly, the AI agent and is going to become one of the biggest business, and the MCP is playing a very, 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 very critical role over there, right? It basically defines that how the models, how the tools, how the models are going to talk with the different tools, right? We'll be in some of the next videos in this series, we'll be talking more in depth about the MCP protocol as well. Um, okay, so we discuss about this tool, and one of the example that I always give, right? Who is the Prime Minister of Singapore? I mean, if the LLM is trained across 1 year old data, it will just not know the recent Prime Minister, right, of Singapore. So one of the best example of using a tool is basically, hey, a model can now do a Google search or access to the latest data or whatever search it wants to do to get an information about the newer prime minister, right? Because the LLM is usually trained on a 1 year old data because it goes through all those fine tunings and other stuffs as well. Then going across to the last layer, that is an orchestration layer. Talking about the last layer, that is an orchestration layer, right? Which um, forms the closed loop of an agent, right? Or it basically keeps on looping the things, right? Or you can say that it's basically defining the cyclic process, right? It defines the cyclic process, right? What does the agent do, right? What does the agent do? Agent reasons, takes action, takes decision, what to do, takes certain action, and again this cycle continues till the time that the conversation is over, right? So this keeps on going into a loop, right? Until when? Until goal is achieved. Until goal is achieved, right? And then when the goal is achieved, that will be stopping point, right? That will be a stopping point. Now to make this to make this work, right? To make this work, keep on doing these goals and decisions. Um, you can take certain examples, right? One of the good examples is the flight booking. I want to do a flight booking, right? I will take an example of this um, over here, right? So if I want to do a flight booking, I need to do this reasoning. I need to do reasoning, right? I will take an example of flight booking. There are a couple of frameworks that are used for doing reasoning and other stuff, right? React, chain of thought, tree of thought, and few others, right? Chain of thought is all basically in all these three frameworks, right? You define certain prompts, you give certain examples, and so on, right? So it's all a prompt engineering, right? Prompt engineering frameworks. These all three are prompt engineering frameworks. So it basically just I mean, React is basically uh, it gives a thought process. It gives a thought process. All three are prompt engineering framework. So thought process to reason and take action, right? Reason and take the action, right? Some examples may be given, or even if the examples are not given, it will still be taking those actions, right? That is, even if the context is provided or context is not provided, it will still work, right? With or without context. It doesn't even have a context of it. You don't have any information about it, right? It will still work, right? Just assume that if it is a senior guy within the team, you give a context or you don't give a context. Sometimes you even don't give a context, it will still work. But if there is certain junior guy, if you don't give a context, I mean, and then this is not true with junior and senior, right? It also depends on the people as well. um, but some people can still take without the context. Some people need a detailed context about it before actually they can start doing something. It is very very good, and it's very it's I mean its performance is very good across certain baselines, right? For a React chain of thought is basically another reasoning capabilities through the intermediate steps, right? So it breaks into the intermediate steps. So there are again various subcategories of chain of thoughts that can include like self consistency, active prompt, multimodal, and so on. And each of it is having its own strength and weaknesses, right? So I'm not going to go into the all subcategories of it. Maybe it can be a separate one when we want to. But it basically breaks into the intermediate steps, right? And this one goes uh, a step across. If you refer to this word, right? It's a tree. So it basically does further exploration of each path. So instead of just following one path, doing a chain of thought, following a path, and then again thinking a next step, it actually creates multiple trees in parallel and takes the best possible at the end of day, right? So it's more like a random forest and decision tree and random forest, right? I mean, it is going to take multiple trees and then takes the best one, right? Something on those lines. So it's an extension of chain of thought wherein each of the exploration is further taken care. Now, if you think of an example, right? If you think of an example, if you want to do over here, maybe I will take this thing and try to um, um, put an example over there. So if I just take an example of this orchestration layer, right? How do I define this orchestration layer? So this is my orchestration layer, right? And I'm just going to take an example of a React framework, right? Because the reasoning is over here, right? And I just take an example of a React framework. So let's say a user says that, so the question is, I want to book flight. So there will be certain thought, and what does the LLM thinks of it? I should search for flight, right? I should search for the flight. So what tool it is going to do? It is going to take an action to call book flight, book flight tool, right? It is going to call which tool? Book flight tool, right? Book flight tool. Again, I'm taking a very simple example, right? Then what is the input that it needs to give? Let's say I'm talking to go from Singapore to maybe, um, let's say, Malaysia, right? A simple example. So it will basically give a result, right? Output will come that, so this was an input that was given to an action. So output that came in was options that are available, right? Different options available. So, and it will take certain thought. I should give this option to the user, right? I should give option to user. After observing this output, right? It observed this output that was received. There are different options to go from Singapore to Malaysia, and it thought that it should be giving an option to the user. And then final answer that came in was, here are some flights, which one you want to book, something like that, right? So this is one of the example, right? How the React is going to work, right? There is a question, there is a thought, there is a question, there is a thought, there was certain action taken, some input given to an action, it got certain output which was done as an observation, certain thought process was achieved, and certain output was given, right? So this is how a typical React will work, right? React reasoning model, right, will work. And all these things, or this flow or an examples, are actually defined directly inside the, it's directly defined inside the React framework or the reasoning layer while you are defining the agents, right? Okay. So we spoke about all the three layers: orchestration, model, tool, and we also took an example of a React. We'll conclude this first video. We'll be concluding this first video by just putting certain differences. What are the differences between the model, right, which is a language model, and an agent? We'll just summarize it so that we are on the best same page, and close it, right? So what was the problem with the model, right? Knowledge is limited. Knowledge is limited. You remember the training data cutoff, right? Training data cutoff date, right? Because after that it doesn't have a knowledge. If I am using an agent into LLM in a 2025, it only has a knowledge until 2024, right? Because it's trained over there, and training is not a easy task. It is a very expensive task, right? And this, what does this agent do? Knowledge is extended. Knowledge is extended, right, via tools, right? There is some simple interface. It's basically a next word prediction, right, but with more detailed things, right? And unless you are not saving the chat history, chats are not saved, right? But you can store in the chat history and so on. It's simple interface, some predictions, nothing much stored. But here the session history is stored. Session history is managed, right? So that it can be used for predictions on the basis of it, right? There is no native tool. Some tools are native over here. So tools have formed the base. And there is a no native logic layer unless you want to do the prompt engineering. Over here, you have a different logic layer, which actually is useful for reasoning, right? We saw an example of a React, chain of thought, tree of thought, etc., right? So different logic layers can be used over here.